Okay, all yours, Rick.
All right, thanks, Ken, and thank everybody for being here. I'm happy to be here and join this group and talk about my research project. So, what I've been working on is using subliminal priming to test the consciousness causes collapse interpretation of quantum mechanics. So, just a little bit about the consciousness causes collapse interpretation. It was suggested by John von Neumann back in 1932. It found some early support, and then it was later expanded upon by Eugene Wigner in 1961, who kind of brought it to a more mature statement. And basically, what it means is there's no clear end in this interpretation. Is there's no clear end to the physical superposition with the mathematics. According to John von Neumann, you could place collapse anywhere on the causal chain from the physical measurement device all the way to the experimenter's subjective perception. So it's reasonable to conclude, or you could, that both the particle under consideration, along with the physical measurement device itself, are existing in a state of superposition until they're observed by the experimenter. The only clear place to draw the line of collapse is at the point in which it interacts with consciousness. And many of you are all probably familiar with Wigner's friend and how he came to that conclusion with the fact that consciousness can't be in superposition. So I just highlighted below that according to this interpretation, the wave function doesn't collapse until the quantum phenomena enters in until the interactions with the physical measurement. The wave function doesn't collapse when the quantum phenomena interacts with the physical measurement device, but only when somebody sees it, when the experimenter's consciousness observes the measurement result. So I was thinking for many years.
Ask a question. I mean, sorry,
yeah,
I forgot the format. Should we chat in the middle, or how do we do it, Rick? What would you prefer, or we wait till the end?
I think I can go as questions as we go along. I think that'd be all right.
Okay, all right. Maybe it's a quick one. So, is consciousness associated with a sentient being? I don't know even what that means, but I mean, is a cockroach conscious? Can a cockroach observe the experiment in this previous slide context? Or can an amoeba, can a virus observe? I mean, where do we draw that line? Or maybe you're going to talk about that too.
No, that's a great question. It's an excellent question. I don't know. I'm assuming that I'm conscious and that all humans are conscious. That's my assumption. And then I think animal consciousness, or how to work in animals, amoebas, cockroaches, are all potentially empirical questions that could be addressed.
Okay.
That's what I got at the moment for that.
So
the big question for me is there a way to tell if the physical measurement device caused collapse, or if it only occurred when I looked at the output on the measurement device? So for example, if I have a Geiger counter and a source of radioactive decay, and I put it in another room, that's collecting, data on the radioactive decay. And if I come look at it an hour later, does the superposition last for the hour before I look at it? Or does the superposition end right at the moment when the Geiger counter clicks? How do you tell what this is? So the big question leads to the big problem. How do you know if something happened without observing it? It seems almost like, well, that's impossible. How can you ever know if anything happened without observing it? And the analogy I like to use, I like to think about this as the refrigerator and the light on inside the refrigerator. When you open up the door, you see the light. When you close the door, the light's off. But I never see the darkness. I never see the darkness in the refrigerator because every time I open it, I'm turning on the light. In the same way, you can't see the superposition, the uncollapsed wave function. You don't see, multiple things happening that are mutually exclusive towards each other. As soon as you see it, it collapses and you just see one thing. It's just like how you can't see the darkness inside the refrigerator. So what can we do? We cheat. We cheat with subliminal priming. Subliminal priming is a method from experimental psychology that I think is going to allow us to measure the effect of something without ever consciously observing it. Using subliminal priming, I think we can see the superposition without collapsing it. Just like the guy, I thought that was funny with the finger on the button. I don't know if you guys ever did that when you were a kid, but I did. So In cognitive psychology, the term priming refers to an effect where exposure to one stimulus influences a person's response to another stimulus. So I'll take you through this type of a test. So you'll have one key, person sitting in front of a computer, and they'll have one key that they'll hit if they see a positive word, and another key that they're supposed to hit if they see a negative word. And let's say the word is happy. If I show the word love right before the word happy, I'm like immediately before, I'm already leaning in the positive direction. And then I can hit happy quicker. I respond to that, in milliseconds faster than if I was flashed a word like pain or sadness or sickness right before happy, because that would get me leaning in the opposite direction, the negative direction, ready to use the button with my other hand. So psychologists have been exploiting these reaction time effects for years as a way to, it's a multi-purpose research tool. But the basic thing behind it is that stimulus items are responded to faster when they're preceded by primes that are congruent, and they take longer to respond. Human beings take longer to respond if they're preceded by primes that are incongruent. So you see right here, love and pain would both be the primes. The stimulus items would be the word happy. So you respond to happy faster following the word love than you would following the word pain. The interesting thing is, in recent years, psychologists have been able to use primes to prime subjects subliminally. So if you take that prime and you squeeze it down to only show it on the screen for 50 milliseconds or less, like 33 milliseconds would work too, and you mask it with nonsense syllables before and afterwards, you can't see that prime. It's hidden from consciousness. And we have no experience of them. And psychologists have been doing things like this where they'd be doing studies and they can prime subjects without the subject seeing the prime. They have no conscious experience of the prime. And even though they have no experience of it, the effects on reaction time are still achieved. So if you have an incongruent prime with the stimulus, it's going to take you longer on average than it would to respond to primes that have stimulus items with congruent primes. But it's all done non-consciously. I want to show you a priming task right now. And before I show it, I just want to explain what you're seeing. Each item is going to start with some nonsense syllables that you can see up there with the number sign, the G and the X and the ampersand. And that's going to remain on the screen for 167 milliseconds. Then it's going to be followed by a prime, which is a whole number that's going to remain on the screen for 50 milliseconds. Then it's immediately going to be followed by a backwards mask, a different type of nonsense letters that's going to remain on the screen for 33 seconds. Then after that, you'll see a number, and that'll be presented on the screen. And on the task, that number that you end up seeing clearly, that's the number that a person had to respond to. And in the task that we use, it's whether or not the number was odd or even. So I'll let you, hopefully this works right here, and we can see it. Oops. Hold on. There you go.
We don't see it.
That?
No.
Okay.
The screen you're sharing is not the screen that's in YouTube.
Okay. I'm going to fix that right now. Now, can you see it?
Yes. Yeah.
Okay. So I'll just kind of let this play for a second. So if I was taking this test, if I was a participant, I'd be like, it's even. I hit the number for 4, which is another even. So you can see it's kind of like a blur. But if you were to take your phone and put it on slow motion and go through frame by frame, you would be able to see the in between that big flash is a whole number, 1 to 9. I don't know if it's going to come up with YouTube being shown on this again, because I can see it's like rendering a little bit funny. But that's what we're talking about. This is the task that the people take.
Okay.
Does anybody have any questions like so far and like what we're seeing or how that part works?
All right. Oh, this is fascinating.
Oh, good. I'm glad you like it. Let me see if I can get back.
So I would say that the flash thing, that the fact that there is a prime in there is unnoticeable. I couldn't catch any priming at all.
Yeah.
It is. I remember the first time I was doing this, I didn't like believe it. So I had to get out my phone and do the slow motion and like, go frame by frame. Like, no, it's in there.
Okay.
So that's how we can, all right. So this is how I use the prime to test the CC. All right. There is some announcements going on. I hope you guys don't hear that. It's just the building that I'm in. The primes, this is how we use the primes to try to test the consciousness causes collapse interpretation. I thought, what if the primes were not determined by me, just, setting up the sequence of primes, but what if they were derived directly from quantum events? Those primes, because they're too short of a duration to be experienced, I think would still be in a state of superposition when the participants took the reaction time test. And here's the hypothesis, is that a prime in a state of superposition should not be able to produce its effect on reaction time because it'll be simultaneously both congruent and incongruent with the stimulus. So for example, if the stimulus was a 5 and the students had to say, the people had to say whether or not it was odd or an even number, the superposition that you would see, which you can't see, would be just, all the numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it would be half even, it would be half odd, and it wouldn't pull in a specific direction. It would just be a superposition of numbers, which wouldn't have the effect. In the same way, if it was definitely a 3, well, then that would help you respond faster to a 5. And if it was definitely a 2, that would make you respond slower to a 5. So this is what we did. We had participants respond each stimulus item, indicating whether it was odd or even by literally saying the words odd or even into the laptop microphone. And then when you started saying the word, the time was recorded in the computer program. Both the primes and the stimulus items were 1-digit numbers, 1 to 9. The sequence of the stimulus items was determined by a classical randomizing algorithm embedded in the program. So just the standard thing that came with the program that determined what number each item was, whether it was a 4, a 5, or 9. But the sequence of primes was derived directly from patterns in a local and private source of radioactive decay. I had a Geiger counter and a piece of uranium ore that was taking, that data. And then every 4 seconds, the amount of clicks during any 4-second interval of time was determining what the prime would be, what prime would be shown. Then the primes were blindly entered into the reaction time code. So when they started, all the primes were totally unobserved. Then once they were entered into the code, I observed with my eyes in the code half of the primes and only half of the primes. And those primes that I observed became the observed condition. And the other half of the primes, they stayed shielded from consciousness. So here's the expectation. If physical measurement caused the collapse, the duration of the superposition, that you can see up there in pink, would be short. The radioactive decay source would have interacted with the Geiger counter, which is the first blue square, and then collapse would have happened right there in that yellow box. Then when it goes into the computer, it's definitely going to be either an odd prime or an even prime. The subjects are going to react to the primes, and then the primes are going to affect reaction times, just as they normally would in your typical psychology experiment that's been done 1,000 times. So if physical measurement caused the collapse, the primes would have worked just as well in the unobserved condition as they would in the observed condition. And whether or not I looked at half of them would have made absolutely no difference. However, if conscious observation caused the collapse, there would have been a difference between the unobserved condition and the observed condition. So you can see at the top of the page in the unobserved condition, the radioactive decay source interacts with the Geiger counter, but if I need consciousness to cause collapse, everything's still in a state of superposition. Then it gets transferred over to the computer, all still in a state of superposition. Inside the code, because I haven't looked at it yet, it was automatically transferred. The odds and the evens are not specifically odd or even. They're still in a state of superposition when the subjects react to them. And if that's the case, the primes don't affect reaction times because they weren't in a definite state, either odd or even. They were in a superposition of both odd or even at the same time. Then in the observed condition, you can see how the duration of the superposition would be shorter. because in the middle, when the experimenter looks at the primes in the program code, they would have collapsed only in that observed condition. And then odd primes would have been definitely odd, even primes would have been definitely even, and the subjects would have reacted to primes that were in a definite state. And that would have had an effect on reaction time. So the hypothesis is that if the CCC interpretation were correct, the primes would have affected reaction times in the observed condition, but not in the unobserved condition. So this is what I got for the first study. And what's reported there in blue is the difference between the congruent and the incongruent primes. So if you look over on the right, you see in the observed condition, the mean response time for congruent primes was 652 milliseconds. And with incongruent primes, it was slower. It was 690 milliseconds. So the response time difference in the observed condition between congruent and incongruent primes was 38 milliseconds. And that difference, over those number of trials resulted in a t-score of 3.19. And that's a p-value of less than 1 in 1,000. In the unobserved condition, this difference was much smaller. It was only 676 in the congruent primes, and with incongruent primes, it was 684. So it was only a difference of 8 milliseconds. And that did not reach the value, the cutoff for statistical significance. The p-value was, the probability of it happening by chance was 0.23, which was well within the statistical margin of error. So it had a big, in this first study, had a big effect in the observed primes had a big effect, and the unobserved primes had a very, very much muted effect that didn't reach the level of statistical significance. And then, I don't know about this level of detail, but I did a t-score comparison because in the unobserved condition, they still went in the way of the congruent primes were still less than the incongruent primes, even though it wasn't statistically significant. So I looked at the t-score difference between the two, and the observed t-score difference of being 2.48, that in and of itself, if you were to calculate that separately, would still be statistically significant. I did it again with a few more subjects, but this time, instead of saying odd or even to the laptop microphone, I upgraded the procedure. So we're just hitting the E key for even and the O key for odd, which is a much, much better way to do it. And we got very similar results. The mean response time difference in the observed condition was 47 milliseconds. And in the unobserved condition, it was much, much lower, only 17 milliseconds. And there's big differences in the significance between both of those, the observed condition and the unobserved condition. I did 2 more studies.
Could I ask a question before you move on there?
Absolutely.
So you are seeing differences that in the first experiment were not statistically significant, and in the second one, it's statistically significant according to sort of traditionally 0.02 is considered statistically significant, but weakly so. So there may be a real effect in the unobserved condition. Do you think maybe some of your subjects were observing the subliminal prime?
It is definitely possible. I think there's multiple things that are happening where that unobserved condition is. I would love to have seen that unobserved condition be 0 or even negative in the other way.
Yeah.
But you'll see as I go through these, it's always less than the observed condition, but it's still there. So I think that's definitely one possibility, is that some subjects are aware of seeing the prime. The other possibility is just decoherence for some, but not all. The other possibility is somehow the primes weren't, well, part of like decoherence is that, it's not stable like a superposition. So what I think is happening is we have a situation in the observed condition where all of the primes are definitely collapsed because I definitely looked at them. And then in the unobserved condition, some of the primes I don't think are collapsed, but some of them are just from error or just from, interacting with the environment. So
there might be spontaneous collapses that aren't caused by consciousness or that are caused by
entanglement somehow, right?
Yeah. It's not, I don't know what I think of decoherence as whether the decoherent states can still be they're not superposed, but they're not collapsed. So I don't know, but that's interesting. Go
That's a
on
good
anyway.
question. That's
Yeah.
a good question. So another question I wanted to bring up too, and I'm not a physicist, I'm a psychologist. So I have, I think, a very good amateur understanding of it. But what I was also thinking of too is like maybe in certain wave functions, the probability of having an odd is going to be higher than having an even, let's say. And then that would also pull it's, I'm probably doing a terrible job explaining this, but if let's say the probability is higher in this particular instance of having an even, it's not exactly 50-50, then I'm going to get an even number more likely. And that's going to, I don't know. I'm
Well, the
confusing
odds,
myself here while I'm talking. Go ahead.
if the numbers are 1 through 9, then the odds of an odd number are higher than an even number because you've got 5 odd numbers and 4 even numbers.
Yeah, I did realize that, while I was doing it, but I didn't. For now on, if I ever do it again, I'm going to get rid of the 9.
Yeah.
Because I don't want to do 10 because 10 was 2 numbers.
Right.
And then I could have done 0, but then people, when I did 0, my subjects were like 0 an even number. And then we wasted a whole, which technically it's not because it's not divisible by 2. But that is, that's not ideal. You're right. It should be. So this is the core of it, experiment 1 and experiment 2. And I tried to do a flourish with experiment 3, and I involved a cat.
Rick, can I ask a related
Oh, sure. Go ahead.
this number business? If you just swap the even and odds, then what happens to each of these hypotheses that were just discussed? You could swap,
Every single,
the role
go
could
ahead.
just be swapped in the experiment.
It would still be exactly the same, I would think.
Okay.
Because we're not, all right, so we're looking at primes that are congruent with the stimulus versus incongruent. That's how everything is being measured. So a congruent prime stimulus pair could be even and even, or it could be odd and odd. An incongruent could be odd and then even, or even and then odd. It's just if they don't match the evenness and the oddness, or if they match the evenness or oddness.
I see. I mean, a related point, do you think you started with an example of happy versus pain or love versus pain. Do you think we're all trained by the time we become adults to have a natural preference for even versus odd because even sounds happy and odd sounds, something fishy about odd versus some kind of psychological bias that we've learned. It has nothing to do with consciousness or anything. It's just some learned response.
I don't think so. That's an interesting question to raise. I didn't use the words. I originally wanted to just use the words, but when you use words, the response times, the differences between congruent and incongruent are smaller. When you use numbers, because it's simpler, people can process it and you get a much bigger difference. And for what I'm trying to do, because this is not like a psychology experiment for the purpose of advancing psychology, I wanted to use this framework to study quantum mechanics. So the numbers make much bigger differences than if I go jealousy, love, beauty, sickness, pain, and death. It also depends on how fast some people can read, and then eyesight and age, because we're talking about words that have multiple letters in it. But there's really nothing. I try to think of the simplest thing I could, and that was a single digit number, odd or even.
Okay.
I did 2 more experiments, 3 and 4, and I added on a third condition, a cat observed condition. And what I assume was going to happen was on the items that the cat observed that, and this goes to your early question about, the cockroach, is that they would act like the human observed condition. Now, how do you make a cat observed condition? This is the first time I tried it, so obviously it can be improved upon. What I did is the Geiger counter makes decently loud clicks. I know my cat's hearing is better than my hearing, but they're not quiet. They're a Geiger counter click. And he was in the room that he normally lays in, and he listened to the clicks while the data was being taken. And that's for both experiments 3 and 4. In experiment 3, I wanted to retest that verbal response modality. So that was just like in experiment 1, we had to say odd or even. Experiment 4 had a keystroke response modality, just like in experiment 2. And then in experiment 4, I wanted to lower the duration of the prime exposure to 33 milliseconds. And I did that because I thought that would cut down on some of those inadvertent collapses. So this is what I got. The human observed condition, there was a difference between, just like the other studies, the mean response time difference was 44 milliseconds. And then I didn't write down all of the chart data, but you can see the unobserved condition was 31 in that third bar. So it was less than the human observed condition, but it wasn't statistically significant this time. On the far right, you can see the cat observed condition, which was much lower. It was only 11. And that was very statistically significantly different than the human observed condition. For sake of looking at it, I collapsed the two unobserved by human conditions, the cat observed condition and the unobserved condition, into a human unobserved condition. And you can compare that, if you wanted to the human condition. And that was statistically significant. On experiment 4, same setup. It's just hitting the keys instead of saying odd or even. We got similar results, except in this one, the human observed condition was statistically significant compared to the unobserved condition in the third blue column. And it was also way larger than the cat observed condition. I did an aggregate analysis of all 4 experiments. And in the human observed condition versus the unobserved condition versus the cat observed condition. And the human observed condition was much more significant than the unobserved or the cat observed. What I want to say about the cat too is people have been bringing up this question, which I think is a very good question. How do I know that the cat was interacting with the Geiger counter clicks? How do I know that he was observing it? I don't. I thought about different ways to do it going forward to make it more obvious, because you could probably pretty easily, every time it clicks, have a light flash or a shadow go on the wall or amplify the sound in some way. I didn't do it on the first time. I wish I did make it a little bit bigger than just the Geiger counter clicks in the room. But I honestly thought that that would work and these would be different. I thought that this would look like a W or a V, with the cat observed looking very much like the human observed.